Today we're going to be doing our soil notes. And just to start off with, I want to talk about why learning about soil is important. A lot of times students don't really get too excited about soil, and I used to not really as well. But what we have to realize is that all life on the planet is dependent on primary productivity, the productivity of plants. In order for plants to be productive, we have to have a beneficial, nutrient-rich soil for them to be planted in. So it's very important for that. And then also later in the year, we'll talk about farming and agriculture and foods. And so we'll tie back into the soil stuff a lot when we get to that unit. Okay, so first of all, we'll talk about what soil actually is. Here it's defined as the weathered portion of Earth's crust that can sustain life. The last set of notes we talked about rocks and how we do chemical and mechanical weathering. So through various types of weathering, we actually break down rock material into soil. We have a lot of chemical alterations happening, especially due to the living things that live in there, which we'll get to the types of things that live in there in a moment. So an important term you need to know in terms of soil terminology is humus. Humus is that really dark soil that we see. It's usually towards the top of our soil layers, and that dark color is usually going to be like a dark brown or a black. It's usually indicative that of a lot of decomposition that's occurred, especially of leaf litter, dead plants that have died and they've been broken down on the soil floor, and we create this nice dark, very nutrient-rich humus. So not only the dead stuff that's been broken down, but it's also made up of droppings. But it's a really good nutrient-rich type of soil, and so you'll hear that term a couple times today. We have young soils, old soils. We have different types of soils for different types of biomes. We're going to be learning what the word leach means here in a second, but generally speaking, young soils usually don't leach very much, while older ones do. Leach a lot of their dissolved nutrients in them. They'll leach it down into lower layers, which we don't want leaching to occur. Okay, so here it shows us that leaching is when minerals dissolve out of the soil. And soil, if you were to pick up a handful of soil, you would have millions of living things residing in your handful of soil. So we have a lot of life that exists in soil, and that life is what helps us to break down the nutrients and to make this humus, this nice dark colored nutrient rich soil. So some of our main players in that would be bacteria, fungi. We've even got lots of different worms. We have insects. We have many more organisms that live in the soil, but these are kind of your main players. And these guys are your main decomposers that help us to create a lot of the nutrients that we get in our soil. Okay, so we already kind of explained leaching a little bit, but this is a pretty good picture. Leaching, we had a lot of our nutrients that are formed up here in these upper layers of the soil. And whenever you have precipitation or any sort of infiltration of water occurring in the soil, it's going to dissolve the nutrients of that soil out of those higher layers, and it'll percolate or move these nutrients down to lower layers. And we're going to look at some pictures of the layering patterns of soil here in a second, and you'll actually see different colors where you can see certain layers have nutrients in them and certain layers have had the nutrients leached out of them. Okay, just some chemical properties of soil, because we're going to be doing some chemical tests in class soon. pH of soil should be anywhere around 6 to 7 for plants. So slightly acidic is okay. And then we're going to have certain elements that we're going to be testing for in soil to make sure that it's a good soil. And again, we'll also do these tests in class, especially nitrogen and phosphorus. We'll come back and talk about them in a moment. But also potassium, which is represented by letter K, calcium, magnesium, and sulfur. Those are all important elements in soil. And the reason that nitrogen and phosphorus are so important is we said that they are major limiting factors for plants. So we always need to test the soil to see if we have enough nitrogen and phosphorus. And if we don't, we're probably going to need to add nitrogen and phosphorus fertilizers to the soil for the sake of the plants. Okay, so we already talked a little bit about pH, but here's just another slide on soil acidity. The acidity would affect the uptake of soil nutrients by plants. And then also, if soil is more acidic, it's going to cause a higher amount of leaching. So we don't want the soil to be too acidic. Last slide we said 6 to 7, but here they're actually saying we could go all the way down to 5.5, and we can be slightly basic up to 8.5 for most plants. Okay, this is a very important slide. Let me get this guy out of the way. Okay, because we're actually going to do another lab where we test these properties of soils too. So, let's start with soil porosity. Porosity is a measure of the volume of your pores, or the amount of space in between each of your particles in soil. And we'll come and look at these pictures over here in a second to see which ones have really high porosity, meaning a lot of space in between their particles, which ones have low porosity, meaning they don't have a lot of space between their particles. Then we have permeability, is the rate at which water actually moves through the soils. And as it says here, that's actually going to be determined by how porous the soil is. And then all of these measures together, plus the texture, which we'll get to on the next slide, are going to determine how well soil can hold on to water, how good it is with aeration, and then how good it is for workability purposes, like tilling it, moving it around for farming. So if we come over these pictures here, this actually shows you an igneous rock. A rock is going to have really low porosity because the particles are really close, really tight together, and that's going to give it very low permeability, meaning that water is not going to be able to move through it very well. Over here, we have the opposite. Over here, we have high porosity. We have a lot of gaps, a lot of spaces in between these particles, and because we have a lot of gaps, you can imagine if you poured some water over it, water is going to be able to trickle through this very easily, so it's got high permeability. Same thing with this picture. Lots of spaces, lots of pores in between the rocks, and they're a very big size of pores, so you're going to have water traveling through it very, very quickly, very easily, so it's high permeability. Let's come to the glacial till. Here we have low porosity because you have lots of little pieces all clamped together. We don't have a whole lot of pore space, so we're going to have low permeability. Water's not going to be able to move through it quickly. And then here we have the same thing. Low porosity, not a whole lot of spaces between the rocks. That's going to be low permeability. And I saved this one for last because this one's actually kind of different. This is clay. And this shows we actually, all these little white spaces indicate holes. So we actually do have some pretty good pore spaces, but because of the way the molecules line up with each other, it actually has low permeability. So clay is kind of a weird soil because it might have some spaces in it, but because of the way that these things line up, water is not going to be able to move through it very well at all. Okay, so here's the texture we talked about on the last slide. We have different categories of soil. We have clays, silts, sand, and if we look over here in this jar, it kind of shows us the different sizes of these particles. Generally, sand is a larger particle, even though when we think of sand, we think of little tiny particles, but sand is generally a larger particle with really good porosity. It's got a lot of pore space in between pieces. Even your finer sand does too. Silt is going to be a finer soil. Think of silt, you think of like rubbing it between your fingers. It's very kind of silky. It's pretty fine, but it's not as fine as clay. Clay is your smallest, finest particle. So if we look over here at this triangle, at this diagram, we can see where these different types of soils kind of stack up. And you can see your clays up here. We can see there's combinations of all the different types of them. You can have sandy clays, you can have silty clays. Then we have silt down here, and then we have sand over here. Now, the interesting thing is when you combine all three of those different types of soils together, clay, silt, and sand, we get what's called loam. And loam is like the farmer's delight. They love loam. Loam is like the best kind of soil you can have for all of the different properties we're going to look at the chart on the next page. It's got great aeration. It's got great workability. It's a farmer's number one choice of soil to have for agricultural purposes. Okay, so here's a chart outlining the 4 different types of soils we've talked about. Clay is really clingy, little teeny tiny particles that really stick together, very kind of sticky type soil, so it really holds on to stuff well, it holds on to nutrients well. But because it's so sticky and because those little particles are so tight and it has such low porosity, It actually does not filtrate water very well. Once water gets into it, it clings onto it just like it does to nutrients. So it's kind of like clingy type soil. And because we said the particles are so tight together, it's got poor aeration, and aeration just means, ability of air to get into the soil. And it's got really poor workability, and with workability we mean ability of farmers to be able to move and plow and till that soil around. So clay is not a popular choice by farmers. Silt we can see is medium for everything, so silt's really not too bad. And let's come down to sand. Sand, again, you think of sand running it through your hands. It's very loose. It's not very tight. So as far as nutrient capacity, it does not hold on to nutrients very well because it doesn't cling together very well. Think about pouring water over sand. Water's going to run right through sand because it has really high porosity. So it has really high permeability. Water holding capacity, because water runs through it so fast, it does not hold onto it very well. Aeration, you can add air to it. It's very aerated because it's very loose, so it has good aeration. It has very, very good workability. It's very easy to move around. However, when we add all of these properties up, sand is actually not a good soil to grow crops in, especially because it doesn't hold on to nutrients well and it doesn't hold on to water well. And then here we have the star of the soil. We have the loam. Loam is also medium in everything, but again, that's good because it's going to be really good at holding on to nutrients, really good at holding on to water, but still water can infiltrate it, and it's very workable. So farmers really like and prefer loam. Okay, so we're going to talk about the different layers of soil, and the different layers, a lot of times they're called soil horizons. And we'll look at some profiles. Profiles are just your pictures where you can see the different horizons in the soil. The top layer of soil is always called the O horizon, O for organic, because you have a layer of surface litter on top where you've got dying, dead leaves and other debris that's still in the process of being broken down. So that's the O layer. The A layer comes below that. That's your layer of topsoil. Topsoil is very important. That's where we're making humus. That's where we're actually partially breaking down stuff as well. And so these top two layers are really important because it says that's where we have, top two, have your organisms, fungi, bacteria, protists that are going to help to do decomposition and break down these organic solids. And then also we said topsoil is very, very important because it's very nutrient rich, and that's what's going to help us to grow crops. So it's very important for agriculture. A lot of our diagrams don't have the next one in their pictures, but a lot of times you have an E horizon below these top two layers. E stands for alluviated, and this means that this like third layer is generally a layer that's heavily leached. So it's usually going to be like a lighter color. So again, I'll show you that in the pictures. And then below that, you might have a B horizon, which we call the subsoil, which really is just broken down rock because it's going to be right above the parent rock, and I'll show you what that looks like. And a lot of times it's a zone of illuvation, which means it's receiving the leach material from that E layer. And then once we get down to the C layer, we're just looking at the rock that's below the soil. And again, the rock, we can call it bedrock, parent rock, whatever, but that's actually, we're making soil from eroded rock. So that's just a layer below these upper layers of soil. Okay, so here's our pictures. Here's our organic layer. Here's the topsoil layer. We don't have that E layer there, but it's a little bit lighter here, but in a better picture, you'd have a nice light layer where we'd see that you actually have leaching happening in this E layer, and then the nutrients leach would go down to this B layer. And then here's C. C, we just said, is the parent bedrock from which soil is actually made. Okay, here in this picture we see layers, some that are darker, like here, some that are lighter. A darker layer would indicate a layer where it's receiving nutrients from an above layer. And then the above layer would be lighter because it's having nutrients leached out of it. So here's the illuviated layer, and here's the one that's getting the nutrients illuvated. Same thing here, illuviated. This one's illuvated. It gets the nutrients. And we see the same thing over here in this picture. Okay, so we said earlier different types of biomes have different types of soil. These are just generalizations, but generally Coniferous forests have acidic soil. It's not suitable for agriculture usually because it's extremely acidic and because we have high leaching, and we have high leaching because you get a lot of rainfall there. So those are like your pine tree forest. The temperate deciduous forest is where we live. These forests actually have decent soil. It says that they have a gray-brown color soil. Actually has high level of nutrients in it. Even though we have a lot of precipitation, which generates a lot of leaching, we still have pretty high fertility because whenever we decompose leaf litter, it's constantly being replaced. So even though we have a pretty decent decomposition rate, we constantly have dead leaves and dead plants that are being added, and we're constantly replacing litter. So we usually have a pretty fertile type of soil in our biome. Okay, the third one would be a temperate grassland. Temperate grassland actually has pretty decent soil. It says they have a fertile, thick topsoil layer. They usually keep a high level of humus on the top of their soil, and one of the reasons for this is that they actually don't have that bad of leaching because they've got a big part of the year that's actually considered a dry season, and leaching occurs due to severe rain. So it depends on how severe their rainy season is, but because they've got that dry season, they generally are able to keep a pretty good top layer of soil. Deserts, as you can imagine, have pretty bad soil, even though they have little leaching because they don't have very much precipitation. They have very low nutrients to begin with, so their soil is not really that great for growing plants. And then lastly, a rainforest, kind of interesting here, they actually tend to have low nutrient levels due to extremely high levels of leaching. And they have extremely high levels of leaching because they have extreme precipitation. So that precipitation is constantly dissolving and leaching the nutrients from the top layers of the soil down to bottom layers. And then also, their rate of decomposition is so fast that almost as soon as dead stuff falls to the ground, it's going to be decomposed. Okay, soil erosion. Soil erosion is the movement of soil components from one place to another, usually from wind, water, or ice. Plants anchor the soil so that it is not washed away faster than it forms. So plants are very important for leaching. Farming, logging, construction, overgrazing, off-road vehicles, they can all increase soil erosion. Losing topsoil makes soil less fertile and decreases its water holding capacity. Also, adding those sediments into water can have a really bad effect on the wildlife that lives in water, and it can actually clog up lakes and streams as well. How serious is global erosion? Topsoil is eroding faster than it forms on about a third of the Earth's cropland. Each year we have millions of more people to feed because our population is growing, but we're losing topsoil at a very fast rate as well. Cost of erosion worldwide is costing us about $4 billion. And in the U.S., soil is eroding 16 times faster than it can be replaced. Okay, and I'm going to stop these notes for now. We're going to do a part 2 so that these notes don't run too long. So I will post the second one momentarily.